Hey everybody, welcome back. Today we're going to take a look at section 12.2 permutations and combinations. Main ideas here: solving permutations and solving combinations, new vocab, permutation, a linear permutation, and a combination. So let's take a little look at softball here before we get started. If the manager of a softball team fills out her team's lineup before the game, the order in which she fills out the name determines the order in which the players will bat. So let's suppose she has 7 players in mind for the top 4 spots. We can use the fundamental counting principle to figure out how many different ways she can order her lineup. So for instance, in spot number 1 she has 7 different options. Spot number 2 would be 6, spot number 3 5, spot number 4 4. Multiply all those together thanks to the fundamental counting principle, and that means there's 840 different ways that she can order the top 4 lineup spots. This idea, when you arrange a group of objects or people in a certain order, is what we call a permutation. A permutation is where order matters. The order is very important. More specifically, if we're putting it in a line, then we call it a linear permutation. Here's the formula for finding a permutation. The number of permutations of n distinct objects taken r at a time is given by the formula P of n choose r, which is equal to n factorial divided by n minus r factorial. Alright, let's talk about this factorial first. Factorial can be found on your calculator. So everyone has a little bit different calculator, so you'll have to find where yours is. A factorial means every integer multiplied together on down to 1. So for instance, 3 factorial is described as 3 times 2 times 1, or 6. 5 factorial, oops, sorry, back up a little bit here. 5 factorial can be described as 5 times 4 times 3 times 2 times 1, or 120. So n factorial is described as that number times every integer on down to 1. The one exception is 0 factorial. 0 factorial is actually equal to 1. Now let's play a little bit on the calculator. And again, your calculator might be different than mine, so you'll have to play around with your calculator to locate this factorial button. If you're having a problem finding it, feel free to speak with me and I can locate you to the right spot. On the TI-84 series, we're going to find the factorial under math. So I want to go 3, math. I'm actually going to scroll all the way over here to this PRB button. And number 4 is going to be our factorial sign. No, that's not an exclamation point. 3 factorial, press enter, gives me 6. Let's try 5 factorial, 120, and one more, just to show you that I'm not crazy, 0 factorial is 1. And there you go. So, that's the factorial. Factorial is used in our permutation formula. So, let's give this a try. First problem. 8 people enter the best pie contest. How many ways can blue, red, and green ribbons be awarded? So I have 8 people entering this contest. It matters who gets the blue, who gets the red, and who gets the green. And since it matters who gets which color ribbon, order makes a difference here. And since order matters, this is what makes it a permutation. Now, the n represents the number you're choosing from. In this case, I'm choosing from 8 contestants. The R represents the number of people or number of objects you're putting in order. Since I have 3 ribbons to give out, I have 3 different places I need to order. So my permutation is 8 choose 3. 8 choose 3. 8 people choosing 3. If I follow the formula, this says we'll take 8 factorial divided by 8 minus 3 factorial. Now, factorials grow very, very fast. So on your calculator, it's not going to be able to handle some of these big factorials that you try to do. So your best bet is to try to simplify first. So 8 factorial over 5 factorial is actually, I'm going to come down here, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 5 factorial, which is 5 times 4 times 3 times 2 times 1. And you can see 1's cancel, 2's cancel, 3's cancel, 4's cancel, and 5's cancel. So I'm left with simply 8 times 7 times 6. 8 times 7 times 6. Or 336. Now, depending on your calculator, you may actually be able to handle this given expression. You'll just have to try out your calculator in a little bit and see how it works. Let's see if this one can handle it. 8 factorial divided by 5 factorial. Now, notice the parentheses that I'm putting each of these in. I want to make it very clear to the calculator what I want in the numerator and what I want in the denominator. So make sure you're doing the same with your calculator. Looks like my calculator can't handle this. Spits out the answer at 336. Now, there's a shorthand notation on majority of calculators. That shorthand notation looks like this. This is your permutation button. This button does this formula for you, which means it saves time. It means you don't have to do all this work. On the TI-84, it can be found directly above the factorial sign. Now, the way we type this in is you're going to first type your n, which in this case was 8. I want a permutation, so I'm going to find that NPR button. And R is 3. So this now says permutation, 8 objects, choosing 3. And when you press enter, 336. Okay, let's try another one. Here we have 10 people competing in a swim race where 4 ribbons will be given. How many ways can blue, red, green, and yellow ribbons be given? Again, 10 people swimming. I have 4 ribbons being given. It matters whether I get a blue, red, green, or yellow because that determines which place I finish in. And because of that, order matters, which means this is a permutation problem. There are 10 total people, and I am choosing 4. 10p4. Or, if you prefer, p of 10, comma, 4. Now, if you're not lucky enough to have the button on your calculator for permutation, we can simply follow the formula, which would be a 10 factorial over 10 minus 4 factorial. If we are lucky enough to have the button on the calculator, it's just a simple matter of going 10 permutation 4, press enter. Looks like the answer is 5,040. So, 10 people in a swimming race. There are 5,040 different ways that they can finish first, second, third, and fourth. Okay, now, permutations and repetitions. Sometimes we're trying to put things in order, but it's possible you have something repeat. So for instance, if we're dealing with letters, I might have 2 of the same letters, so it doesn't matter whether T comes first or T comes first. If they're the same, it doesn't matter the place that they're in. So if I have something with repetitions, the way I find the number of permutations of n objects, of which P are like and Q are like, is given by n factorial divided by P factorial Q factorial. Now, this can be extended based on how many different objects are repeated. So I can continue this on. If I have 3 objects repeated, I would just say p factorial, q factorial, s factorial, so on and so forth. So let's look at how many different ways we can take the letters in the word banana and rearrange it. Well, if I look at the words banana, I have 1, 2, 3, 4, 5, 6 letters. So, permutation-wise, 6 different letters means I should be able to arrange this 6 factorial different ways. However, I have things that repeat. Because the A repeats 1, 2, 3 times, I'm going to take my 6 factorial and divide by 3 factorial. I also have an n, which repeats twice. So I'm going to take that n, which appears twice, and I will also divide by 2 factorial. The B for banana only appears once, so I don't have to necessarily put that. I can if I want, by simply writing 1 factorial, that it's there once, but 1 factorial is just 1, so it's not going to affect my problem at all. So it doesn't hurt either way, whether or not you have it. Now, let's take out our calculator, let's plug it in. Again, be very careful what you want in the numerator and what you want in the denominator. So 6 factorial is my numerator, and I want to divide by 3 factorial times 2 factorial times 1 factorial, which gives me 60 different options for the way this word banana can be split up. All right, let's give another one a try. How many different ways can the letters of the word algebra be arranged? So again, let's talk about how many letters there actually are in algebra. 1, 2, 3, 4, 5, 6, 7 different letters, which means the number of ways I can order those 7 letters is simply 7 factorial. And I want to divide that by the number of times any letter repeats. Looks like I have A twice, so I'm going to divide by 2 factorial. I have an L, I have a G, I have an E, I have a B, I have an R. All these other letters appear only once, which means they're all going to be 1 factorial. Now, if I want again, I can write down 1 factorial, 1 factorial, 1 factorial, 1 factorial, but 1 factorial is simply 1, so I'm just going to simply simplify things and leave it as 7 factorial over 2 factorial. Pull out my calculator. 7 factorial is 5040. Divide by 2 factorial. 2 factorial is just simply 2, so I just divide that by 2, and I get an answer of 2,520. So the word algebra can be arranged 2,520 different ways. Now, second big thing from this lesson is combinations. If it's not a permutation, it's a combination. A combination is a way of ordering things which order does not matter. So basically, you're putting people in groups. The difference here is permutation says, let's take 5 kids. Let's stand them in order from tallest to shortest. Combination says, let's take 5 kids and put them in a group. No order. That's the difference between a combination and a permutation. Formula for combination is given as n factorial over n minus r factorial. So if you look at just that part, that's your permutation. But then combination adds an extra r factorial on the bottom. Reason why there are more permutations than there are combinations because permutations in order matters. Combination, a group of 5 is one group of 5. But in a permutation, you can take that group of 5 and you can order them different ways. In fact, you can order them 120 different ways. So permutations are always bigger than combinations. Combinations, just like permutations, has a button on the calculator. You may choose to use this formula if you want, or you may choose to use your combination formula, which is usually hidden right around the permutation button. And here you can see NCR, so it's number 3. So let's give some a try. 5 cousins at a family reunion decide that 3 of them go pick up pizza. How many ways can they choose 3 people? to go? Well, we have 5 cousins. 3 of them are going to pick up the pizza. Order does not matter. They're just trying to group 3 of them together. Since order doesn't matter, this has to be a combination problem. 5 people choosing 3. So, 5 total people choosing 3 to go on the trip means we have 10 different ways we can select people to go get the pizza. Let's try another one. 6 friends at a party decide that 3 of them will go pick up a movie. How many ways can they choose the 3 people go? Again, order does not matter. Because order doesn't matter, this becomes a combination. 6 total people. We're choosing 3 of them. So I have 6 choose 3. And 6 choose 3 gives me an answer of 20. So there are 20 different ways I can group these 6 people together to go pick up the movie. All right, very good. A couple more left. So, multiple events. If you have multiple events, what you do is you figure out each event, how many can happen from each event. And then fundamental counting principle tells me let's multiply those 2 things together. So let's assume 6 cards are drawn from a standard deck of cards. How many hands consist of 2 hearts and 4 spades? So, first thing you know about a standard deck of cards is how many hearts and how many spades there are. Well, there's 13 hearts, there's 13 spades. For those of you who don't know cards very well, there's also 13 clubs and 13 diamonds. So I want to choose 6 cards. Let's start off with the 2 hearts. There's 13 hearts. I want to choose 2. Notice, order does not matter. 13 hearts, choose 2. Doesn't matter how they come. Order doesn't matter. I then want to choose 4 spades. So, let's switch colors here. This is hard to see. We'll go red. There are 13 spades. We want to choose 4 of them. Again, order doesn't matter, so that's why it's a combination. 2 separate events. Fundamental counting principle tells me let's multiply them 2 together. So let's see what we got on our calculator here. We'll go 13 choose 2, which gives me the answer of 78. We'll go 13 choose 4, gives me an answer of 715, and 715 times 78 gives me an answer of 55,770 different ways. So if I pick 6 cards from a deck, I'm looking for 2 hearts and 4 spades. There's 55,770 different ways I can get 2 hearts and 4 spades. Pretty amazing. Alright, let's try one more of those. 13 cards are drawn from a standard deck of cards. How many hands consist of 6 hearts and 7 diamonds? So let's start with the hearts. Again, there are 13 hearts in a standard deck of cards. It does not matter how I get those 6 hearts, so order is out, which means this is combination. So 13 choose 6. There are 13 diamonds in a standard deck of cards. It does not matter how I receive those cards, so that means this is a combination, and I'm choosing 7. And we'll multiply those 2 numbers together. So we will have, shrink things up a little bit here, 13 choose 6, which is 1,716, and 13 choose 7, which is, oh, look at that, 1,716. So we'll go 1,716 times 1,716. Wow. Big number here. So, there are 1,716 ways to choose 6 hearts, 1,716 ways to choose 7 diamonds. If I put those together, that means there is, looks like 2,944,656 different ways that I can get 6 hearts and 7 diamonds. Pretty remarkable. Alright, I got 3 problems here for you to try. A standard deck of cards. We have people being selected for a committee, and one more dealing with cards. Permutations, combinations. I'm not going to tell you which one, but remember, that's the key. Figure out, does order matter? If order matters, that's a permutation. If order does not matter, that's your combination. Have a good night, and we'll see you tomorrow in class.